Okay, so our next video is about coordinate geometry and quadrilaterals, and I included, Derek has this and I saw him using it, but this is a very helpful document about the properties of quadrilaterals that will help you to solve problems. So I want you to just review that document and make sure that you understand the theorems about it, especially about the diagonals. That's an important piece. And again, it's a two-page document. Our first sample question is about a quadrilateral that has integer coefficient or coordinates, and it also has to deal with similarity. Okay, so similarity comes up a lot in our course, but basically quadrilateral QRST is similar to ABCD. So S and T correspond to C and D. That means that Q and R are going to be below the T and the S. It's going to be similar, like an enlargement and a translation of that object. I noticed that CD has a length of 3 and TS has a length of 6. So basically it's going to double in size. So I'm going to go from T, I want to know about Q. I'm going to go down, instead of going down 3 like I do from here to here, I go down 3. I'm going to actually go down 3 and then 6. So I was at -1, so that put me at -7. And instead of going over 1 to get to the next point, I'm going to go over 2 to get to the next point. So that's a coordinate of -3, -7. That would be my Q. And actually that's right here. Multiple choice answer C. All right, these theorems keep going. We just did the one on coordinate geometry. They can also be done without coordinate geometry. We're looking at an algebra problem here, and the question is, what statement best explains why the equation x plus 5 equals 2x minus 3 can be used to solve for x? And this is straight off of that 2-page document. This is a rhombus, it tells me in the problem. So a rhombus has diagonals that bisect each other, meaning that this piece is equal to this piece because it's bisected by this diagonal. So that would be answer choice B. Sample question number 2 involves a statement and reason proof, and I'm going to look over my givens. I'm going to look at the figure to figure out what I need to do to prove that something is a parallelogram. So you want to take a minute to do that. I would start by marking the picture, which maybe you can use on the exam. I guess you really can't mark it on the computer screen, but what you can do is just sketch it on your scratch paper so that you will be able to make markings on it. So here's PS is congruent to QR, and ST is congruent to TQ. So I've got that marked. And then also given is that angle TSR, okay, that's this one, is congruent to angle TQP. Got it. So that's all my given information. Now the question is, for step 4, why is angle QTP, all right, so let me mark that. I'm going to use a different color so that we could see it better. Why is this congruent to RTS rather, so this one? And hopefully you realize that the reason for that is that these are vertical angles. Now, the next question would be, why are the two triangles congruent to one another? And when I look at the two triangles, I see 2 pair of angles and 2 pair of sides that are congruent. But if I look at just one piece of it at a time, like this piece here, this triangle here. Why is this triangle, STR, congruent to QTP, this triangle? And I can see that that is going to be angle, side, angle. Okay, the next thing would be they're using CPCTC, okay, and what would be true if those two triangles are congruent? And I'm going to look at the statement piece right here. This statement here is what I'm looking at. Is PQ congruent to SR? Maybe. So let's look at the next choice. ST congruent to TR? No, because that doesn't line up with the values that are in here, or the order of the letters is what I'm looking at in this statement. So ST does not correspond to TR, so I'm going to cross that out. PT congruent to TR. PT congruent to TR, maybe. Let me go back and look at the last one. PR congruent to QS. No, that doesn't match. So I'm going to cross that out. Now for the other two, I'm going to go back and I'm going to look at the picture. PQ congruent to SR. Let me go up and take a look. PQ congruent to SR. Yeah, I think that we could say that that is true. I would not say that we wouldn't probably use choice C, because the next step in our proof is to prove that this is a parallelogram, and in a parallelogram both pairs of opposite sides of a quadrilateral are congruent to the quadrilateral. And what I get from choosing choice A is that now I have side PS. Let me choose even a fourth color so I could just really highlight what we have. I have PS congruent to QR. That was part of my given. And then if I use this statement by CPCTC, now I have both pairs of opposite sides of the quadrilateral being congruent. So that's really what drives me to say it's not going to be C, but I can say that it is answer choice A. Okay, next we're going to look at proving triangles are congruent or similar, and then also the CPCTC part. And just remember that the corresponding parts of congruent triangles are congruent. That theorem only applies for congruent triangles, and it's only used after you've proven that the triangles are congruent. So shown here on this slide are the methods for proving triangles to be congruent, and we are familiar with all of these. Remember that hypotenuse leg is an example of angle side side, which is normally no good, but it does apply only in the case of right triangles. Then we can also look at similarity theorems, and there are two of them that we've been studying, and that is the angle-angle theorem. If you can show that two angles are congruent, then the triangles are similar. And remember that similarity means that you're going to be able to set up a proportion and solve for missing sides and things like that, as we've done already in a couple of these problems. And then side, side, side for similarity, I want you to be sure to understand that this is not the same side, side, side as the one for congruence. What this means is that you can take those sides and set up proportions like you see here to solve. If this is all true, then you can say that the triangles are similar. Okay, and our first sample question, and it's a shout out for Dog Lips because I know she loves flow proofs, and that's basically what we have here. So I'm going to suggest again that you start on the left side and you start marking your picture. You're going to want to resketch that on your scrap paper and start marking it up. Let me just get a better color than green because it's hard to see. XZ is the perpendicular bisector of WY. So that means that I have perpendicular angles or right angles right there, and also that since it's a bisector, these two little segments are congruent. And then at the top in the middle, you can see that XZ is congruent to XC by the reflexive property. We got that. And so I've marked this by definition of perpendicular bisector, and I've marked this by definition of perpendicular bisector again. So now you see down here at this point, they're talking about all right angles are congruent. I mean, that seems kind of intuitive, but it is something that we include in a proof. So just kind of keep that in mind. Now the question is right here. This is what they're asking us to find. Why are the triangles congruent? And when we look at the picture, I can think about hypotenuse leg. That would work because these are right triangles. However, I don't have any information about the hypotenuse. So hypotenuse leg is out. However, I do have, looks like side angle side here. So let me go down and see. This is a multiple, yep, there it is. It's a multiple choice question, and there's side angle side there. So the answer is C.